Hello, my dear students. Today I am going to just explain the concept of equivalent mass. As we know, the formula of equivalent mass, actually for various substances like elements, ions, salts, acids or bases, we have different formulae. Okay, they are actually similar formulae, there is no large difference in the formulae. Let's see, when you talk about equivalent mass of an element, then it should be atomic mass of that element upon valence of that element. You know, valence depends on group number. And ions, whatever the ions that is given in the question, so by looking at the ion, you can find the charge. Okay, whatever, whether it is negative or positive charge, number of units of charge you see, that should be in the denominator. And when you talk about salts, generally formula mass, because salts do not have any molecular formula, they have empirical formula. So for salts, instead of molecular mass, we say formula mass. Okay, that calculation is similar to that of molecular mass. So charge on either cation or anion, any one you have to take, not both. And when it comes to acids or bases, molecular mass, that we know upon n factor. So I will explain about n factor of that one. So first let me take some examples of this. When you take some elements like sodium, aluminum, magnesium, like that, some oxygen. Okay, then how to calculate the equivalent mass? You know, atomic mass, that is fixed for element sodium, that is 23 upon what is the number of valence, valence of sodium, that is 1. So it should be 23 U or AMU if it is equivalent mass. If it is gram equivalent mass, then unit should be 23 grams. Okay, so like that, aluminum, you see 27, its atomic mass upon its valence is 3. We know group third element, group 13, 3A or group 13. Okay, 9 units. Similarly, magnesium 24 atomic mass upon valence is 2, as per its group number it is 12 units. Oxygen is 16 upon its valence is 2, group 16 elements have valence of 2, so it should be 8 units. But here one point I want to highlight: oxygen you take in atomic state or molecular state, O2 or ozone, O3, whatever it may be. Not only oxygen, every element in its atomic state or molecular state have same equivalent mass. Oxygen atom has 8 units of atomic mass. Oxygen molecule also has 8 units of mass. Oxygen molecule 32 upon single oxygen valence is 2. So 2 oxygens valence should be 4. Again 8 units is there. Okay, so this is the actual calculation of equivalent mass. So equivalent mass of atom or its molecule, homoatomic molecule, must be same. So when it comes to some ions, like you have many ions, calcium plus 2, okay, carbonate ion, so chloride ion, like this, anyone. So first you calculate formula mass, that is easy. Calcium atomic mass is 40, we know, upon what is the charge? 2. And carbonate 12 plus 3 into 16, 48 upon charge is minus 2. So you take the units, because mass can never be negative. And Cl minus, the atomic mass is 35.5 upon the number of units of charge, that is 1. You take 1. So you can simplify like this. Okay, so for elements and ions you can calculate like this. For salts it is just like ions. Suppose you are given NaCl, magnesium sulfate, calcium chloride, any salt you are given. Then how to calculate equivalent mass? Its formula mass, sodium, that is 23 plus chlorine 35.5. The calculation of formula mass is quite similar to that of molecular mass. But for ionic compounds we can't use the term molecular mass, because in ionic compounds they don't have molecular formula, we know. Okay, so NaCl and charge on cation or anion, any one. You know, in NaCl sodium has plus charge and Cl has minus 1 charge. You take 1, any one. Okay, either cation or anion. Like this magnesium sulfate, we know, plus 2 and minus 2. Plus 2 minus 1, minus 1 is there, but 2 chloride ions are there. 2 into minus 1 is minus 2. So either cation or anion you take. And you know how to calculate formula mass. Magnesium 24 plus sulfur 32 plus 4 into 16 64. Calcium 40 plus 2 into 35.5 71. That you can simplify. You know how to simplify addition, that division everybody knows, no doubt. So this is very useful information, because all types of species, I mean elements, ions, salts, acids, bases are there. I mean the calculation is there on a single, I mean frame, single tabular form. Okay, so let me explain how to calculate n factor of acids and bases, because that is going to play a very important role in calculation of equivalent mass of acids and bases. In salts, actually you can use one more formula. Salt, cation and anion are there, na? So in a particular salt, equivalent mass of salt is equal to that equivalent mass of cation plus that of anion. That is also correct. Individually you can calculate equivalent masses of cation and anion separately, and you add them. That is also another method. That is also true, correct. I mean you will get the same answer. So when it comes to acid we have base, various acids and bases. But how to calculate n factor? In case of acids, n factor is always number of replaceable hydrogens. And here in case of bases, n factor is number of OH minus ions furnished by the base. Generally the bases which can furnish OH minus ions when dissolved in water are generally alkalis. Alkalis are soluble bases. Okay. So in this, what is this replaceable hydrogen, sir? Actually, when we are given any acid, how to identify this particular acid has 2 replaceable hydrogens, 1 replaceable hydrogen? How to find? It is actually the number of H plus ions furnished by the given acid. Like you see, HCl can furnish 1 H plus, sulfuric acid can furnish 2 H plus ions. This is nothing but n factor, because you know how to calculate molecular mass. So by knowing n factor, you can easily calculate the equivalent mass. You have H3PO4, H3PO2, this is 1. Acetic acid, you know about this, this is 1. Okay, like this, you have formic acid as well, 1. So actually, some students make some mistakes, that what they think, whatever the number of hydrogens visible in the acid, that should be equal to the n factor of that acid. That is actually misconception, because that is true in some cases, like HCl, H2SO4, H3PO4, that is true. But you see, in class 10 also you have studied about acetic acid or ethanoic acid. Although 4 hydrogens are present, they are all not replaceable. Okay, only 1 is replaceable. You see, methanoic acid, 2 hydrogens are there, only 1 is replaceable. So replaceable hydrogen means this one, number of H plus ions furnished. So in H3PO4 actually 3 are visible. Okay, no, 3, because in oxy acids, number of hydrogens which are directly attached to oxygen is nothing but n factor, that is basicity of an acid. H3PO3 is like this, H3PO2 is like this. So oxy acids are those acids in which hydrogen ion, I mean H plus ion donation takes place from OH group. How many OH groups are there? 3 OH groups are there. So n factor is 3. That is in fact basicity of an acid. 2 OH groups are there. It can furnish 2 H plus ions. Basicity is 2. That basicity is nothing but n factor. OH, only 1 OH. These are not replaceable. So in oxy acid, the replaceable hydrogen must be attached to oxygen. Okay, H3PO4, H3PO3, H3PO2, although these three acids have same number of hydrogens, but basicity or N factor is totally different. The terminology N factor is used only in case of equivalent mass. Like you know, ethanoic acid, you are very familiar to this. Ethanoic acid, although 4 hydrogens are there, but how many are replaceable? You see, the hydrogen which is attached to oxygen is replaceable. Formic acid or methanoic acid, you all know, only this one is replaceable. So this is the way to calculate N factor. But if you know N factor, then you put in the formula molecular mass, all of you know how to calculate, and take N factor, you will get equivalent mass. Okay, so in case of acids, N factor is also called basicity. And for bases, it is even more easy than acids, because in acids somewhere you have to find what is the basicity, I mean how many replaceable hydrogens are there. But such kind of problem won't arise in case of bases, because in case of bases, by looking at the base you can find how many OH groups are there. Okay, sodium hydroxide, only one OH group, it can furnish one hydroxide ion. KOH can furnish 2. Magnesium 3, AlOH thrice 3, magnesium hydroxide 2, sorry. Actually aluminum hydroxide is not a base, but when question is given in the examination, you take 3. Aluminum hydroxide is amphoteric. So well, like this. What about ammonia, sir? In ammonia there is no OH group. Actually ammonia is gas. In gaseous phase there is no reaction. It has to be dissolved in solvent like water, then it gives ammonium hydroxide. So although it is a weak base, so it can donate one hydroxide ion when dissolved in water. So its N factor should be 1. Okay, so for most of the bases there will be no problem. By looking at number of OH groups you can find N factor. Okay, and I will make one more video in that I will explain the calculation of N factor in redox reactions, oxidizing agent, reducing agent, and N factor calculation of oxidizing agent, reducing agent in disproportionation reactions, and overall N factor of disproportionation reaction. There is a separate video for that.